Hello and welcome to Excel Mathematics TV. This presentation will be about multiplying and dividing integers. In this lesson, we're going to learn how to multiply and divide integers. Let's start with the rules in multiplying two integers with different signs. Multiplying integers is the same as multiplying whole numbers, except the rules for signs. When we multiply two integers with different signs, the product is always negative. A positive integer times a negative integer is equal to a negative integer. Here's an example. 3 times negative 6 equals negative 18. The sign of 3 is positive, while the sign of negative 6 is negative. The signs are different, so the product is negative. A negative integer times a positive integer is equal to a negative integer. Here's an example. Negative 3 times 6 equals negative 18. The sign of negative 3 is negative, while the sign of 6 is positive. Here the signs are different, so the product is negative. Let's apply the rules to answer the following examples. For number 1, find 5 times negative 7. Start by identifying the signs. 5 is positive, while negative 7 is negative. The signs are different. According to the rule, the product of two integers with different signs is always negative, so the product is negative. Thus, 5 times negative 7 equals negative 35. For number 2, find negative 10 times 4. Start by identifying the signs. Negative 10 is negative, while 4 is positive. The signs are different. According to the rule, the product of two integers with different signs is always negative. Then, the product is negative. Thus, negative 10 times 4 equals negative 40. Now, let's study the rules in multiplying two integers with the same sign. When we multiply two integers with the same sign, the product is always positive. A positive integer times a positive integer is equal to a positive integer. Here's an example. 3 times 6 equals 18. The signs of 3 and 6 are the same. They are both positive, and their product is positive as well. A negative integer times a negative integer is equal to a positive integer. Here's an example. Negative 3 times negative 6 equals 18. The signs of negative 3 and negative 6 are the same. They are both negative, and their product is positive. Let's apply the rules to answer the following examples. For number 3, find 2 times 12. Start by identifying the signs. 2 is positive, and 12 is also positive. Both are positive, so our product is positive as well. Thus, 2 times 12 equals 24. For number 4, find negative 8 times negative 9. Start by identifying the signs. Negative 8 is negative, and negative 9 is also negative. Both are negative, so our product is positive. Thus, negative 8 times negative 9 equals 72. The next topic is multiplying more than two integers. According to the associative property of multiplication, the grouping of numbers in a multiplication sequence does not affect the sum or product. It states that the quantity of A times B times C equals A times the quantity of B times C. Here's an example. 5. Find negative 1 times 6 times negative 4. Applying the associative property gives us negative 1 times 6 times negative 4 is equal to the quantity of negative 1 times 6 times negative 4. We will solve the factor negative 1 and 6 inside the bracket. Identify the signs. Negative 1 is negative, while 6 is positive. The signs are different, so the sign will be negative. Multiplying negative 1 and 6 gives us negative 6. Now we have negative 1 times 6 times negative 4 equals negative 6 times negative 4. We will multiply negative 6 and negative 4. By identifying the signs, we see that negative 6 is negative, and negative 4 is also negative. Both are negative, so the sign will be positive. Multiplying negative 6 and negative 4 gives us 24. Thus, negative 1 times 6 times negative 4 equals 24. Here's another example. For number 6, find negative 3 times negative 11 times negative 2. Applying the associative property gives us the quantity of negative 3 times negative 11 times negative 2. Like what we did on the previous example, we will solve the factors -3 and -11 inside the bracket. Identify the signs. -3 is negative, and -11 is also negative. Both are negative, so the sign is positive. Multiplying -3 and -11 gives us 33. Now we have 33 times -2. We will multiply 33 and -2. We have to identify the signs. 33 is positive, while -2 is negative. The signs are different, so the sign will end up being negative. Multiplying gives us -66. Thus, -3 times -11 times -2 equals -66. Now, let's study the rules in dividing integers. The rules in dividing integers are similar with the rules in multiplying integers. When we divide two integers with different signs, the quotient is always negative. A positive integer divided by a negative integer is equal to a negative integer. Here's an example. 3 divided by -6 is equal to -1/2. The signs are different, so the quotient will be negative. A negative integer divided by a positive integer is equal to a negative integer. Here's an example. -3 divided by 6 is equal to -1/2. The signs are different, so the quotient is negative. When we divide two integers with the same sign, the quotient is always positive. A positive integer divided by a positive integer is equal to a positive integer. Here's an example. 3 divided by 6 is equal to 1/2. The signs are the same. Then the quotient is positive. Also, a negative integer divided by a negative integer is equal to a positive integer. Here's an example. -3 divided by -6 is equal to 1/2. The signs are the same, so the quotient is positive. Let's apply the rules to solve the following examples. For number 7, find -36 divided by -4. Start by identifying the signs. -36 is negative, and -4 is also negative. Both are negative. Then the quotient is positive. Thus, -36 divided by -4 equals 9. For number 8, find 50 divided by -2. 50 is positive, while -2 is negative. The signs are different, so the quotient will also be negative. Thus, 50 divided by -2 is -25. Let's try some more examples. For number 9, find -40 divided by 5. Start by identifying the signs. -40 is negative, while 5 is positive. The signs are different, so the quotient is negative. Thus, -40 divided by 5 is equal to -8. For number 10, find 52 divided by 4. Start by identifying the signs yet again. 52 is positive and 4 is also positive. Both are positive, so the quotient will be positive. Thus, 52 divided by 4 equals 13. The next topic is evaluating algebraic expressions. Evaluate each expression if x equals -2, y equals 9, and z equals -13. For number 11, the given algebraic expression is 3x plus 7. Substituting x equals -2 into 3x plus 7 gives us 3 times -2 plus 7. We will multiply 3 and -2. 3 is positive, while -2 is negative. The signs are different. Then the product of 3 and -2 is negative. So we have -6 plus 7, and adding gives us 1. Here's another example. For number 12, the given algebraic expression is y minus z over x. Substituting x equals -2, y equals 9, and z equals -13 into y minus z over x gives us 9 minus -13 over -2. To subtract, add the opposite of -13, which is 13. Add 9 and 13, and we have 22 over -2. The quotient of 22 and -2 is negative, and dividing will give us -11. Our lesson about multiplying and dividing integers ends here. We learned how to multiply and divide integers. We also learned how to evaluate algebraic expressions. Thank you, and we'll see you next time.